Okay, welcome to Geomatic. This is another example about the concept of inertial and non-inertial frame of references and pseudoforce, where we are studying the motion of an objects that are located in an accelerated frame of reference. Okay, you can check the previous videos about such concept and the introductory video to the concept of frame references. Okay, first of all, a frictionless cart of mass m equal 100 kilogram carries other two frictionless cart also, friction equal to 0 in this question, 1 and 2 having masses 8 kilogram and 4 kilogram respectively, connected by a string passing over a massless pulley. So we have here T, and this is T, this is T, this is T, because summation of torque equal to 0, that means T1 equal to T2 equal to T, right? What horizontal force F must be applied on the cart so that the smaller cart does not slide? Does not slide meaning that M2 summation of forces along the y-axis equal to 0. So it's not sliding up or down, okay? First of all, since we have a moving cart with force F, external force F, meaning we have an acceleration A to the right, and since M1 and M2 are located on this accelerated cart, that means M1 and M2 are located in an accelerated frame of reference, which is the cart M. Now, for such type of exercises, we can solve by two ways. First way, which is case 1, we observe the motion from an inertial frame of reference. Okay, that means observer here. Then we solve such type of exercises by saying that the system as a whole is moving to the right. We apply Newton's second law on the system, summation of force equal to the mass total of the system multiplied by acceleration. We have only one external force F equal to the mass total, meaning M1 plus M2 plus big M, multiplied by acceleration A, and we get that force equal to M 100 kilogram, M1 8 kilogram, and the M2 4 kilogram, and we get 112A. This is first formula. Concerning the second formula, we have to apply Newton's second law on M1 and M2. Now, since M1 and M2 are not moving with respect to the cart, so acceleration of M1 with respect to the cart equal to 0, but acceleration of M1 with respect to the ground, where an observer is standing, is not 0, because M1 and M2 are within the system which is moving to the right with acceleration A, right? So M1, if you want to think about it, M1, summation of forces applied on M1 along the axis of motion, x-axis here, equal to M1 multiplied by A, right? Forces are only tension, equal to M1 multiplied by A. Okay, on M2, we have here a normal force along the x-axis, a normal force equal to M2A, okay? But along the y-axis, we have a tension equal to M2G. Now, we will not use the formula of N equal M2A in this exercise. Usually, we use it when there is a friction between M2 and the cart. So, friction equal to coefficient of friction multiplied by normal force, so we use it. But in this exercise, we will not use it. Then tension equal to tension, thus M1A equal to M2G. So we get acceleration equal to M2G, which is 40 over 8, equal to 5 meters per second square. Now we apply it here, so we get force F equal to 112 multiplied by 5, we get equal to 560 Newton. And thus the answer is C. Now we can observe the motion from a different frame, which is a non-inertial frame of reference, and we mean by that the observer now is standing within the accelerated frame of reference. Thus we get case 2, observing from non-inertial frame of reference. Okay, then frame of reference, okay, Then, of course, we have summation of forces equal to M total A. We mean by that the force equal to 112 acceleration. We have this formula. And the other formulas on M1, now the block M1, this is tension, and this is, now we consider pseudo force, F, right? Pseudo force F equal as direction minus MA, as magnitude F equal to MA. Now, since M1 is not sliding with respect to the accelerated frame of reference, which is the cart, then we get summation of forces equal to 0. Y equal to 0 in this case and equal to M1A in the case 1. Because in M1, in case 1, we are visualizing or observing the motion of the cart from the perspective of the observer who was standing in the inertial frame of reference. But here we are observing the motion of a cart from the accelerated frame of reference. He is observing the M1 if it's moving or not. Since it's not moving with respect to the accelerated frame of reference, then summation of force equal to 0. And we get force F, okay, plus T equal to 0. That means tension equal to force F, pseudo force, which is equal to MA. Okay, this is the second formula. And the same concerning M2. We'll have also, okay, N equal summation of force along the x-axis equal to 0. We have N plus pseudo force, okay, pseudo force equal to 0. And then N equal MA. Will not use this equation here, but we use the equation along the y-axis equal to 0. Then we'll get that mg equal to a tension, m2g equal to tension here, m1a, okay. This third equation, tension equal to tension. Then we get m1a equal to m2g, okay. Then acceleration equal to m2g over m1 equal to 5 meter per second square, okay. Then we apply it also here, okay. Then force F equal 112 multiplied by 5 equal to 560 Newton. The same answer, same result. Okay, so in such type of exercises, as we have said, we are studying the motion of an objects which are located in an accelerated frame of reference. So we are studying the motion of an object in accelerated frame of reference from two different frames, either accelerated frame of reference itself or from the inertial frame of reference, which is the ground. Okay, if you have any question, drop them in the comment section below and stay safe.